All right. Our learning targets for today are for you to walk out of here with the ability to factor an expression into an equivalent polynomial. A lot of fancy words there, but basically we're just going to be doing everything that we've done already backwards. And that's what the word factor means, to undo the multiplication process. We're going to be able to find the GCF, the greatest common factor of an expression. And so that's some of our vocabulary for today. GCF, greatest common factor, which is the largest number, variable, or combination of the two that can be found in terms of the same expression. So anything that they have in common and the most that they have in common would be part of your GCF. And then again, factoring, like I said, is just the ability to rewrite an expression in a different form, but an equivalent form. And it's going to look like the distribution property. Okay? Let's take a look at a couple. So, first one. Let's say we have the expression 6x squared plus 15x. Well, we want to see what the largest number and variable that are in both of these. Since it's a binomial, there are two terms. So we want to try to figure out what they have in common. Some of you already know this, but just to go through the process for those that maybe don't, 6 can be rewritten as 2 times 3. And x to the second power has 2 x's. That's why there's a 2 there. And then 15x, well, that can be rewritten as 3 times 5 times x. I rewrite it in its most simplest form with the smallest numbers because those numbers are prime. So those numbers can't be factored again. Now we look for ones that they have in common. So there's a 3 here and a 3 here. They have that in common. There's 1x here, there's another x here. So the GCF of this binomial right here, the largest thing that can go into both, is a 3x. Okay? So what we've done is we've actually put that in. And so this was the answer you got after you distributed. So I put a line here, I labeled it the GCF, and then I set up parentheses, because that's what the distribution property looks like. Now the 3x is what we distributed in, because that's what it had in common. That's why both of those had it. But what was in the parentheses to start? Well, if distribution is multiplication, I can use division to undo that multiplication. So divide by 3x, divide by the GCF, and you're going to end up with 2 here. Remember, our exponent rules when we're dividing is to subtract. So 2 minus 1 is simply 1x. 15 divided by 3 is 5. And 1 over 1, 1 minus 1, is going to cancel out. So there you have it. You got your 2x plus 5 going into the parentheses. And so that is the answer, which is the opposite of distributing. You have factored. Now, if you were to distribute, just one way to quickly check, you're going to get this right here. You're going to get what you started with. Okay? Let's just talk about the GCF for a little bit, okay? Just try to figure out what number can go into both terms. Go into both terms and how many variables they have in common. One thing that we could do is use our calculator. So if we want to find the greatest common factor between 12 and 18, go ahead and bring up your calculator. All right. Oh, you know what? That jumped over here. There we go. And go ahead and press the math button. Obviously, the math button probably does something important. And then you have actually 4 tabs up at the top. So click over one to the number tab. And then if you go down, and if you go down far enough, all the way down to number 9, it will bring up GCD. Okay? Now that's obviously not GCF, but it's greatest common denominator. And it's the same concept as the greatest common factor. So press number 9 or press enter, and then type in the 2 numbers, 12 and 18. So 12, and then use a comma and 18. Close the parenthesis. I'll wait just a second for you to see that. Once you press in 12, 18, you press enter, and it tells you that it's 6. Now that kind of made sense. The biggest number that can go into 12 and 18 is in fact 6. So there you have it. So the greatest common factor is 6. Now if this has 3 x's and this only has 1 x, how many x's do they have in common? Well, obviously just 1. So there you have it, your GCF for the first one. Next one, 5x to the fourth, 25x to the second. Greatest common factor. Biggest thing they have in common. Well, always look to the smallest number. In this case, 5. 5 can go into itself, but nothing else, because 5 is a prime number. Does 5 go into 25? It does, okay? Sometimes they don't have a number in common. Sometimes they do. This one has 4 x's here and 2 x's here. For how many in common? A total of 2, okay? And if you want to write those out, you can. You got 4 x's and 2 x's, so there's 2 that they have in common. Don't add them up. You're just trying to see what it is that they have. Next one, 21 and 14. Again, we want to try to think about the greatest common factor. And when some of these are kind of obvious, you don't have to use the calculator. But if you need to, I'll show you one more time. So again, press the math button. You got to go over 1 to the number. You see how the black is now highlighting NUM? And then we want to go down to number 9. I'm just going to press 9 and it will bring me right to it. It was 14 and 21. So 14 comma 21, close the parenthesis. I think most of you are going to know this. It's 7, right? 7 is the biggest number that goes into both of those. So voila, we come up with a GCF, and now what do they have in common? Well, it's got to be the same variable. So it's got to be x squared with x. So there's 1x that they have in common. If this has 5y's and this has 7y's, the most that they have in common, that's the key, is 5. Okay? All 3. Okay? So when we've got 24, 16, and 8, it's got to be there. So always look to the smallest number and start there. Does 8 go into 16? Yeah, 2 times. And does 8 go into 24? Yes. So I'm going to skip the calculator for this one. Just say that the GCF has an 8 in it. Now think of these as 3 individual pieces. 3 x's, 2 x's, 1 x. So because this is the smallest number of x's, that's going to be the greatest common factor because they all have at least just 1 x. And then finally, 20, negative 12, and 28. Ignoring the negative, let's try the calculator for this one. Now with the calculator, go ahead, press math, number, so go over to the right one, and then it's 9 for the GCD, greatest common denominator, greatest common factor. Use the smallest 2 numbers, but use the positive version. So 12, comma, 20. Okay, and use the smallest ones, because then we can always check the larger one. Close the parenthesis, press enter. 4. Does 4 go into 28? Yes, so that's got to be our greatest common factor. So the GCF of these 3 numbers is 4. I get that we didn't do all 3, but the calculator cannot handle 3. So just do the smallest 2. And then from there, try to see what variables they have in common. Again, 3 there, 2 there, only 1 there. So it's not the biggest number of variables, it's the most that they have in common, and that is only 1. There's only 1 x that they have in common. We're going to write a polynomial that has been factored, okay? So remember that this is the answer to a distribution problem, where there is a number here and something inside those parentheses that I distributed to. Now my job is to figure out what I distributed, what the GCF is, and to figure out what was in the parentheses. Well, 3x minus 24. There's no variable they have in common because only 1x here, nothing there. So that don't have that variable in common. 3 is a prime number, and you always look to the smallest. Does 3 go into 24? It does. You could always check that with a normal calculator by dividing. So we take that GCF and we divide by 3. Once you divide by 3, that's going to give us 1x. 24 divided by 3 is 8. And that is what goes in the parentheses. Because, think about it. 3 times x, 3x. 3 times 8, negative 24. You're creating an equivalent or equal expression that's in distribution property form. Let's keep it going here. And believe me, just setting these up for yourself will make you more successful. So what's the biggest number that can go into 6 and 10? Look at the smaller number. Does 6 go into 10? No. Other numbers that go into 6, 3 doesn't go into 10, 2. So 2 is the biggest number that goes into both. This has 2 x's, this has 1 x, so they have 1 x in common. Go ahead, divide by that GCF. Once you divide by the GCF, what's left? 3x plus 10 divided by 2, 5, 1 minus 1 cancels. This goes in the parentheses. And again, you could always check yourself. 2x times 3x, 6x squared. 2x times 5, 10x. Okay? I'm going to give you the chance to try C on your own, and then we'll go over it together. So, we want to try to find the greatest common factor and what would be left after I factor that out. Well, 5 is the biggest number that goes into 10 and 35. Kind of obvious there because if it ends in 0 or 5, it's going to be 5. Now, what about the variables? There's 3 here and 2 here. 3 of them and 2 of them. So that means both of them have at least 2. So we can say x to the second power. Now we come back and we divide out the GCF. We want to undo that distributive, undo that multiplication. So 10 divided by 5 is 2. Subtract your exponents like we've done in the past. 3 minus 2 is 1. And then 35 divided by 5, it is a negative, so negative 7. X squared over x squared, that's going to cancel out. Take what you got left and put it in the parentheses. And there you go. Okay? Any questions on what you did compared to what I did, please let me know. This time, we've got a trinomial. So, when it's a trinomial, guess what? The greatest common factor has to be in all 3 pieces. This has 2 x's, this has an x, this has no x's, no variable, no x in common. 4 is the smallest number, so let's start there. Does 4 go into 8? No. Yes. Does 4 go into 24? Yes. So there it is. 4 is the greatest common factor. Now we take that out. So 4 divided by 4 is simply x squared. 8 divided by 4 is 2x. 24 divided by 4 is 6. If you don't get a whole number, or an integer for that matter, you've done something wrong. All of these numbers should be non-decimals. Go ahead, put this part into the parentheses, and you have rewritten it as the distribution property. 2 to go. Let's try this. 6x to the third minus 8x squared plus 2x. Yes, it has to be in all 3 for it to be the GCF. Now, why do I say start with the smallest number? Because 6 can't go into 2, nor can 8. So I start with 2. Does 2 go into 8 and 6? Yes. Without even using the calculator, you know that. Now this has 3 x's, this has 2, and this has 1. They all have at least 1 x in common. So I'm going to go ahead, divide by that 2x. Once you get there, we've done this before. 6 divided by 2 is 3. X to the third over x to the first. Subtract the exponents. We've got 2 left. Negative 8 divided by 2 is negative 4. X squared over x to the first. There's 1 left. And 2x divided by 2x does kind of cancel, but it makes a 1. And so if you start with a trinomial, you have to finish with a trinomial. Now, sometimes it's easier to take what you got left and put the GCF out in front. And remember, you can always double check to make sure that it's going to be the same. Go ahead, let's try to do F on your own right now. So there you have it, folks. The GCF was 8x, and once you divide, you get that trinomial, and you have completely factored this using GCF.